Hello, my name is Hemant Kumar, and this is a short demo video of how to install and run my project that is called priority-based parking system. So it's actually a vehicle movement analysis and insight generation in a college campus using Edge AI. So what this basically means is that whenever a vehicle enters or exits a college campus, we take an image of the vehicle along with the license plate, and we try to analyze based on what time did the vehicle come, what number plate, which state does it belong to, is it registered, not registered. Try to make a inside generation, right, using Edge AI. That means all the processing computation happens locally in the local machine. Nowhere cloud is used, right? With the basics, let us start. So my recommendation is go through the readme file. It has detailed steps. I have made detailed steps about these things, and the demo what I'll be making will also be available here. So let's start with the cloning of the repo. So just copy it, right? I'll go to my desktop. I'll take a terminal. I'll go to my desktop. I'll make a directory called demo, right? So I have a demo. Inside it's empty, right? So I'll go into my demo, and here it's empty, right? Okay, now I'll git clone it. It will take a few minutes because it has a lot of images and binary files to download, so please wait for a few minutes. Okay, so now the cloning is done. You can see we have all the files. Next, what you do is go into the directory, right? We are inside the directory, and what I want to do is install the dependencies first. So here you can see requirements.txt file, right? So all the requirements what are used in this project are available here with the versions. You can have a look. So that's what we'll do now. We'll pip install requirements. I won't be doing it because I already done it, right? Do it once it's done. So the next what you have to do is copy the custom license font trained data, the Tesseract. So you have to paste this command next. So what we are basically doing is license plate dot train data, right? So this is the license plate dot train data. So I'll show you with one example. Look at the input images, right? We have the input images. For example, the text which are very clear, the font which can be easily analyzed, which are not on the HSRP number plate, right? For example, font like this are easily identified because it's a plain text and there's a clear differentiation between words. Like A and 4, you can have a difference. There is a difference, you can make it out easily. But when it comes to like HSRP number plates, so when you look at images like this, see K, A, 4, it has a distinctiveness. Same with here, you can easily make out the difference between A and 4, and also Tesseract easily identifies it. But when we come to like HSRP number plates, majority used in India, A and 4, see there's a very similarity in between. So this causes errors in detection. So in order to avoid that, what I did is there's this font called license plate. The font looks something like this, right? It has a close resemblance to the HSRP number plates. So I have trained Tesseract using this, and that obtained data what I have, you have to paste it in the Tesseract directory. That's what I'm telling here. Like sudo copy this license train data into this directory. Make sure the version of the Tesseract what you're using is correctly given in the command. Okay, that is done. Okay, once that is done, I won't be doing this. Okay, I won't be pasting this command now because I already did it. And the next thing what you have to do is whitelisting few characters. What is mean by whitelisting is only allowing those characters to read from the data. For example, when you take a look at this, see we have K01 something, but it is after reading K01, it is detecting some non-recognizable characters, the characters which are not available. So it gives something which we don't want, right? It's not desirable. So what we'll do is I made a custom like config file which has which allows only these things, only these characters from capital A to Z and from number 0 to 9, right? Also it is available in the directory. You have to just copy it and paste it. Make sure again the Tesseract version is proper. Okay, you can see it here. It has custom.txt. This file you have to paste it, the config file. Fine, that's all the pasting, and that's it. Next, coming to vehicle.ods. Okay, so here in the directory we have vehicle.ods. So basically it has all the entries of the vehicles. Okay, whatever the Tesseract detected, in my case this is what I have uploaded it. Okay, but because you have to see for yourself, right? So what I do is like right click this and move to trash or delete it, or you can just copy this command. It will delete the vehicle.ods. Right, see the vehicle.ods file is removed. Good. So next you shouldn't worry because the vehicle.ods file will be made available when the program runs it again. So next, this will be the main command to run single instance of a single image. What I mean by that is, let me copy this. So here we are, this is the main.py file, and that is what we are running in the Python, and with passing with few parameters here. So let me open this in any IDE. I'll take PyCharm. For example, you can use VS Code. So yeah, this is the main.py file. So let me quickly explain what all these files do. The main.py, it mainly has the YOLOv4 class. So it tries to calculate the bounding boxes, make predictions. Right, from there we are calling character recognition, and that will go take us to the character recognition. Actually, we are importing it and we are directly executing it. And here you can see. So basically, it takes date and time, and next it takes license plate info. The code is commented. You can have a thorough look. And after all this thing, the main will call the ODS file, right? We have calling ODS file. What this ODS file does is it takes all the data and puts it into the vehicle.ods. That means it creates an Excel file kind of. ODS is the alternative to Excel. So it checks whether the directory has the ODS file vehicle.ods. If it doesn't, it creates it on its own with these parameters as the column names, and then it starts to input there, right? So you can also execute the command from here, or for the easiness you can also execute from here. Take the terminal from the bottom and you can just paste it, right? I'm pasting this command to run single instance of a single image, and make sure here you replace the image with a proper image name, right? So the input images has from image 0 all the way to image 108 208. So give any number between. Okay, I'll just press enter, and you can see it has already created all this, like it extracted license plate, vehicle, status, entry, exit. Is it registered or not? It is registered. Then what time or what date, how much is occupied, how much space is available, is it 2-wheeler, 4-wheeler? Okay, everything is taken. So see, we have now vehicle.ods file, and it has that information available here. And one thing is we have registered vehicles. So this it compares, right? Suppose think your college board members, directories, dignitaries, all these important people have their car, right, and they need parking space with with priority, right? So it compares whether the cars is available in this, and it gives a priority. Okay, although that part is not integrated yet, but it will be coming very soon. See, it will check on the registered vehicles one whether it's registered or not. Simple. And then it creates vehicle.ods file. Okay, if you want to see what's happening behind the scenes, for that what I would suggest is go to main.py, and I have commented out few sections so that nothing should pop out when the program runs, but you can change it. Okay, when do one change, basically I'm telling it to show when the program runs, show in main.py, and go to character recognition, and here these two lines, right, uncomment this and uncomment this. Okay, now you can see the glimpse of what's happening behind the scenes. I'll again uh, paste the same thing. Okay, this time I will take it, for example, let us take image 50, for example. Press enter. See, press any key. Okay, this is what we call it as an inference. So it makes an inference. This is basically the YOLO making a prediction, bounding boxes. It identifies as a license plate, and this identifies as a four-wheeler. Right, you can also save it from here wherever you need it, and from that the image is converted applying the best threshold value, right, and the bounding box of the license plate is passed to this image that is extracted using ROI, region of interest, and this is fed to the Tesseract OCR. Now Tesseract reads this and it prints. Okay, press any key and the pop-ups will go. Simple. And it reads it, right? This is the information what we extract, and this will be stored. You can see in the vehicle.ods, this information will be stored. K01MV. See, it's a four-wheeler. That's how simple the program runs. Okay, and along with this, also I would suggest, one second, I will uncomment this back. Okay, so now there are no changes. Fine. So one thing, if you want to see for the all the images, and you have to press each this one, right? Each command you have to paste. For example, for 208 images, you have to place it 208 times. So that can be avoided using this batch.py. Right? That is what discussed in the next region. So you can simply run python 3 batch.py, and from basically it goes through the input images folder, and from here, if from image 0 to image 208, it runs the command for each image, and each image data will be saved, right? So what I will do is I'll go to this. Before you start, to get the accuracy of the data, just delete vehicle.ods, because you don't have to worry, it will be created every time. So I'll take that command. You can either place it here, or you can place it inside the any IDE also. It should be terminal. I'll show you here also. Python 3, I'll take batch.py. See, now it starts with the image 0. It found some information. It's writing there, and here you can observe vehicle.ods file is created. Like that, it continues for whole 208 images. Okay, now the vehicle.ods file, I think it is fully done. Like you can see the last till 208 images, it is done. You can check the vehicle.ods file. You can check the vehicle.ods. Sorry, you will be having all the details. So now one thing to note is this is not all perfect, right? You find missing data here. So that means Tesseract is not reading it properly. Well, that's the issue, because a lot of images are taken with different camera angles, right, with the different lighting conditions. and you can expect these kind of, missing of data. It's fine. Okay, I'll close this vehicle.ods. So the next thing what we can do is, since we have all the vehicle.ods file, all the data inside it, we can have a beautiful presentation of it. So for that, as mentioned here, you can just run python 3 app.py. So basically this app.py, it's a Flask web app. It's a simple app. It converts all the data from the vehicle.ods. This is the index.html from here, right? This is a skeleton of it. So you can just run it. Like, it doesn't matter anywhere, here or here. I'll run it from here. Python 3 app.py. And it gives you a URL. Just right click it and right click or open link or just left click. Anything is fine. It gives the some analysis of what's happening. Vehicle live count is like 49. So that means 49 cars, vehicles are inside the parking lots now. This will be the graph you can see over the time from 8 o'clock to 4:30. The graph, this is the availability, and here this will be the occupants, right? And this will be the vehicle class distribution. Four-wheeler is just 10%, and two-wheeler it's 90% around. And it tells peak maximum occupied time is around 11:14 with 71 vehicles. I think this is the point. Yeah, 11:14 with 71 vehicles. So hope this project make us understand better. Better understanding gives us better understanding about the parking space. More features are yet to be added, like is this vehicle belongs to which state? K means Karnataka, T and Tamil Nadu. Like, there are different states, right? Starts with different letters, naming conventions, and that also we can show. For that, we need more accuracy of the Tesseract. And also one more thing, what we can show is what was the average time of the vehicles that were parked inside, right? Like, there are more and more insights we can generate. For that, Tesseract images, it should read well. And one thing what we can do is take all the images in the, like a similar photo, fix the camera at one angle, and training for the images similar will yield in a better result. So this is the project. Thank you.